If the vertex hk and one additional point on the graph of a quadratic function of f of x equals ax squared plus bx plus c are given to you, then f of x equals a times x minus h all squared plus k can be used to obtain the quadratic function. So we're going to determine the quadratic function whose vertex is 1, -5 and a y-intercept is -3. So we know that 1, -5 is your h and k, and that the y-intercept of -3 is just 0, -3. This is your x and y value. So since we have a point and a vertex, we can use this equation form. So f of x equals a times x minus h squared plus k. So we can say that positive 1, -5 are h and k. So f of x equals a x minus 1 squared minus 5. But we still got to find a. And we can find a by knowing the fact that x is 0 and y is -3, because it gives it to us. So -3 equals a times 0 minus 1 squared minus 5. So -3 equals a, and -1, well, 0 minus 1 is -1, -1 squared is a positive 1, then minus 5. Add 5 over, we're going to get 2 equals a, and this can be used to plug back into here to find our function. So instead of having just a plain a, we can actually say that our function f of x is 2 times x minus 1 squared minus 5. And here is our quadratic function from the given data. Now what if we're not given that stuff? What if we're given something different? We're going to find the quadratic function whose x-intercepts are -3, positive 1, but this time we have a being 1 and a being 2, so we're actually going to have two functions. So we're going to find both quadratic functions. So we know that x equals -3 and x equals 1, but how about instead of doing that, let's go backwards. Let's move everything back to one side and set it equal to 0. So x equals -3, x equals 1, and we're going to add 3 and subtract 1. So we're going to get x plus 3 equals 0, and x minus 1 equals 0. Well, since they're both equal to 0, we can just multiply them back together, kind of like undoing solving. So x plus 3, x minus 1 equals 0. And if we were to FOIL this out, we get something like a quadratic equation. So we can actually kind of just change this up a little bit and say that this is some function f of x with some unknown a, x plus 3, x minus 1. So we have our quadratic function, but we need to know what a is, and we know that a can be a couple different things. In fact, they asked us to find when a is 1 and a is 2. So all you do is just take what a is and set up two different equations. So for the first one, when a is 1, we're going to have f of x equals just x plus 3, x minus 1. And we can FOIL this out and get x squared plus 3x minus x minus 3. And we're going to get x squared plus 2x minus 3. Not too shabby. But what about when a is 2? Well, we can just take the exact same thing here. F of x equals 2 times x plus 3, x minus 1. And we can FOIL it out again, or we can know what the two parentheses multiply out to be, which is just going to be 2 times x squared plus 2x minus 3, and then distribute the 2. So 2x squared plus 4x minus 6. So we have our two functions. This one when a is equal to 1, and this quadratic function when a is equal to 2.